Hey there, welcome YouTube audience. Just chilling here at the Smash News Network, Busted Name and News, and we're going to cover space weather as we've got some incoming space weather action happening right now. So, very high speed solar wind right now. Last I checked, it was over 700 kilometers a second, and yeah, coronal hole high speed stream. It's a really fast one. So. Yeah, it's caused a little bit of geomagnetic storm conditions. So we'll just chill here for a few minutes, folks. Allow people a chance to press refresh on their YouTube feeds. Press the subscribe button if you're new to the channel so you see the content in your feed. And leave a comment and press share. I'm going to step away for a quick moment here, and then I'm going to talk solar data. Probably no weather stuff or other basic everyday news stories today because there's a lot to do, which I'll probably have to tell you about at a later time because it's complicated. All right, so yeah, minor geomagnetic storm conditions. Love to see that. I don't think there was any aurora visible this morning here in Lehigh Valley, Pennsylvania. However, I didn't really wait too long to find out. It was a little on the cool side and it looked like it was cloudy to our north. So I suspect there was not anything to really see there. But I definitely didn't see anything. No green glow, no pink glow, nothing like that. And let's talk about the weather in space. Space, a frontier. These are the voyages of a light that is too bright. Let's just leave it like that. That's fine. All right, so you may be wondering how many sunspots there are. There are a lot. You may be wondering what the solar wind velocity is. It's very fast. You may be wondering what I'm up to on Facebook. You can find us on Facebook, by the way. Then, of course, we did do a live stream yesterday. We used a desktop PC for once, and it was pretty good. But the view count was incredibly low because landscape mode versus portrait mode, I guess. It's very strange. I mean, I guess people don't like to hold their devices sideways. I'm sure most people are viewing the content on mobile devices. All right, in any case, let me bring up the chat just in case somebody decides to strain themselves and actually leave a comment. Don't strain yourself, folks. Don't leave a comment. I know it's too much work to type some characters in the chat. I know it's extremely hard. It's like using your turn signal, you know, you have to like reach and you gotta do work. Which in science, when we say do work, we mean use energy. Terribly sorry if it's too much energy to type a comment. All right. By the way, we've got to get rid of our watermark. If you see a watermark on our live streams, that is an old thing that I got to get rid of on YouTube settings. I'll get around to it eventually. All right, so first thing we want to look at is, do we have any new CMEs on the way to Earth? So I'll show you the HUC forecast here, as we like to do. And I'm just going to press refresh just to make sure that we have the latest. So there you can see that glancing blow. I don't think that hit. Actually, I think it hit ahead of the coronal hole high-speed stream, but it was minor. So that wasn't a major impact, hence the term minor. Thanks for the comment, Stratotanker 8373. That's an old one. Please ignore that. All right, so sunspot number is way up still, folks. Still rising a little bit here since yesterday. Sunspot number now all the way up to 160, 170, 180, about 185 sunspots. So a big uptick here in sunspot number along with space weather action. Look at that, radial flux. Oh, look at this. Solon.info is reporting the sunspot number as 228. So the point is, lots of sunspots, a high radial flux up to 210 solar flux units. It's an active sun. Here's our coronagraph. There was some flaring earlier. Let me shrink this down to show the full image. That's good enough. I think there is another CME headed our way. But let's look at stereo A just to sort of verify that. So on the Integrated Space Weather Analysis Center, just go to Browse, go to Solar, go to Stereo A Core 2 Space Weather Beacon. And it certainly looks like there's another Earth-directed CME. So another one likely to arrive here early in the day on the 6th. So more geomagnetic storm conditions coming our way, folks. We'll show you the filament that erupted, but you'll see some ejecta coming out of your screen left here toward the end of the stereo A imagery, it looks like. There we go. There it is. So also this shows some great organization of the plasma. We do occasionally see this, and we often see this in the solar wind data as well. You can see there's this dense outer shell, and then there's like an empty layer here where it's much less dense. And then there's this very like three-dimensional looking cylindrical bit of ejecta coming out here. If that was headed directly toward Earth, that would be an absolutely major geomagnetic storm. But most of that ejecta will miss Earth to the south. Some of it will strike Earth, though. So expect to see more geomagnetic storm conditions coming on December 6th. So yeah, exciting stuff. What can you say? Fantastic. We'll show you some more data here, like the Space Weather Enthusiast dashboard. Let's see what NOAA's saying about space weather. And they were pretty much right on time for today's coronal hole high-speed stream. It is also referring to combined coronal mass ejection impacts. So there you go. There's NOAA's forecast. That black box there. Expecting geomagnetic storm conditions to continue into tomorrow. Hopefully they'll be stronger than forecasted here, as we hope you get more mid-latitude aurorae at your location. Cylindrical is good, but Bruce prefers conical. I believe that would be a Jamaican bat, if memory serves. Next, we'll talk about the real-time solar wind. It's in near real time, folks. It's measured at Lagrangian 0.1, by the way, if you weren't aware of this. Why does it look so weird? There we go. That's how it's supposed to look. Like I said, current conditions are about 700 kilometers a second, but the field has weakened, so geomagnetic storm conditions are now gone, having reached all the way up to a G2 geomagnetic storm. Ah, yes. Cone-shaped, right, Bruce? Fat at the business end and skinny at the Bruce end. No solar energetic particle events. Things are chill. As far as the solar proton flux goes, it's basically hovering around baseline levels. Like I said earlier, we did have an M-class flare. It was a pretty decent size M6 flare early this morning. And yes, it was associated with a coronal mass ejection. And yes, it does have earthly directed componentry. Next, let's check our magnetic sector. I believe Earth is in a small North Pole oriented sector, but let's just check. This is the last 4 days, actually. South Pole sector. There you go. Earth is still in a South Pole sector. North Pole sector coming soon. But we have coronal holes of both polarities, so that's why we're seeing this, folks. And here's our line of sight coronal hole plot. You'll see both red and green there. Red being the south pole solar magnetism, and green being north pole. So there you go. Solar max conditions continue as far as coronal holes, and exactly as we forecasted, an uptick in coronal holes lasting years, because early in this solar cycle, we had sort of a shortage of coronal holes, and now they're catching up. So there's the latest image. Earth is in a South Pole oriented sector, but this coronal hole is about to snap Earth into a North Pole sector. And if you're scared of sector boundary crossings, then you don't understand things like current sheets. Let's just show the line of sight field plot here just for the fun of it. This combines the gong magnetogram, which you can see there in grayscale. And wow, lots of activity on the Earth side of the disk. Sunspot number may continue to climb here. It's bonkers. All right, so let's take a look at the latest magnetograms here. Our newest data is 23 minutes old. We're going to look at just today's. Wow, that is impressive. So not just a lot of sunspots, but large sunspots. Excuse me. They're not that They're not that magnetically complex. They're not that likely to produce large flares. Continuing right along. Here's our red light. This is red light. We're going to weigh in on those sunspots and see if they've grown, shrunk, etc. And we'll use the time frame just today, December 4th. Holy smokes, Bruce. The brand the Pope smokes. All right, so that's today's action from El Teide, Spain. Let's zoom way in. And those sunspots are almost entirely stable. Look at that. Almost no changes here. Very stable. Still some propensity to produce large flares. And I mean, the most likely spot is going to be probably right here. This looks promising. We do have there's a little bit of change happening in this one. So actually this one over here is actually my favorite to produce another large flare, as limb flares are a little bit more intense and a little bit more likely than center disk flares. Anyway, once again, there's the magnetogram. And there is the red light. Last but not least, the hydrogen alpha imagery. Let's see. So I'll show you where the ejecta came from. It came from just south of this sunspot group. Let's see. We'll stick with El Teide. Since their data looks great, they had clear skies. So yeah, that ejecta came from down here. And again, more earthly directed coronal mass ejections. Looks like the flare actually came from up here. But I'm not too concerned about it. Electron flux has dipped. Now keep in mind, folks, this is actually erroneous data. This has to do with the arrival of the coronal hole high-speed stream. So this gives us a great indication of exactly when the coronal hole high-speed stream arrived. Just keep in mind that we don't really have low electron flux. All right, this is probably actually higher than this, but because the ionosphere puffs up, it induces data anomalies. Because these GOES 19 and GOES 18 satellites, they have to use radiography from about 23,000 miles of altitude, and they're measuring the ionosphere at like 100 kilometers of altitude or something like that. So this is actually erroneous, but it does give us insight into when the coronal hole high-speed stream has arrived. Moving right along here, we're going to show the ionosphere real quick. We'll show the raw data from the previous day and the anomaly in megahertz from the 30-day median, as we like to do on the Daily Space Weather Show. Why? Because GPS errors are induced by high electron flux. And since cyclists like me use GPS a lot, we want to know where that is. Anyway, there's the raw data. That's vibrational frequency in megahertz, millions of vibrations per second. Actually, quite high frequencies here north of the equator, where it's late autumn. You're in the darkest 6 weeks of the year right now for Northern Hemisphere viewers, or the brightest 6 weeks of the year if you're south of the equator, if you're from Munda. So that's the raw vibrational frequency, courtesy Australian Government Bureau Meteorology. And here is the anomaly in megahertz from a 30-day median. Once again, I would note the South Atlantic anomaly is way over here now instead of here or here. It's right here. It's very clear where it is. The South Atlantic anomaly, folks. It moves around quite a bit. And if you don't monitor where it is, you won't know. People who operate satellites do because it matters to them. Anyway, there's the closest star, my favorite to gaze at. The one that convinced me not to become a cosmology major. Yeah, it's true. Yeah, learning about the sun caused me to not major in astronomy and cosmology. It's true. So yeah, there's the ionized helium, and don't be surprised to see additional Earth-directed coronal mass ejections throughout the day. I am closing this thing out. So thanks for tuning in, everybody who has. Once again, congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off, and until next time, may that high-speed coronal wind be at your back.